Hey everyone, I'm Darshan Senthil, and today we're gonna be talking about logarithms. So I know it's a pretty random stray from my usual topic of just basic algebra, but today I decided that I wanted to do something a little bit more advanced, and also logarithms is actually not that hard, and it looks hard to be honest when you see letters or general in like formulas, you generally tend to be a little bit freaked out, like what is this magic or whatever, what is this sorcery. So basically, yeah, I just wanted to explain this to you, and it's honestly not that hard. It's not as hard as it seems. So, if you're like watch, if you just want to watch this before you learn it in school, that'd be very helpful. Because I'm just gonna go over like the basic concepts, like sort of like a base for what you need to know in logarithms. Like everything else that you learn in most algebra classes springs up from the stuff I'm gonna teach you in this video. So I'm just gonna teach you like a foundation, and then maybe I'll do more videos later on more advanced concepts. So this is a good place to start if you want to learn about logarithms. So without further ado, let's get started. So let's just start by defining a logarithm. What exactly is a logarithm? Well, basically, in essence, a logarithm is just a power. That's all it is. A logarithm is a power. That's it. Now you may wonder what I mean by that. And basically all I mean is like you may see like in this particular problem 5 to the second power is 25, and this 2 right here is the answer to is what a logarithm gives you as of your final answer. It gives you a power like this. So let me just give you an example here. So log to 4, this is one of a pretty common ones. So all this is asking you is 2, let's just set that equal to x. So log base 2 of 4 is equal to x. All this is asking you is 2 to the x power is equal to 4. And as you can tell here, you're going to need to know your exponents. So that's something that's pretty critical to logarithms. You need to know your exponents well. So I would advise you to revise those as well just before you started watching this video. Okay? So this is basically asking you 2 to the what power is equal to 4. And if you knew your basic exponents, you know that 2 to the second power is equal to 4. So basically, x is equal to 2. So log base 2 of 4 is equal to 2. That's all a logarithm. And as you can see, a logarithm is nothing more than a power. It's this power up here that is a logarithm. Is what a logarithm tries to give you. Whatever. So this is what it's going to give you. So let's just do another example just to get you a bit fluent with it. Yeah, let's just erase this stuff. Just need some more space. So let's try log base 3 this time of let's say 9. So again, it's helpful to rewrite this as 3 to the, let's make this equal to x. 3 to the x power is equal to 9. It's much nicer to look at this as opposed to this, because this tells you exactly what you need. Like this, you'll need to sort of know it in your head. Like you'll need to know it's this. So if it helps you, it's always good to write it down like this, as in exponent form, so that you know exactly what to solve for. And again, if you knew this, you'd know that x is going to be equal to 2 again. It's that simple. That's all it is. So let's just do one final example, this time with log base 10 to the, let's say 100. Log base 10 100. Actually, let's do 1000. So yeah, 10 to, again we just rewrite it like this. 10 to the what power is equal to 1000. Well, basically, so once again we know that 10 to the third power is equal to 1000. So x is going to be equal to 3. Oh yeah, we have to set that equal to x in this case. So that's all logarithms is, to be honest. So I'm just going to do one more thing here before we move on to the next step. So I'm just going to label the logarithm, just tell you a few of the parts. Here we go. So basically, if you've got a logarithm like this, log base 2 of 4. This thing right here is called your base. That is called what you call your base, because if you rewrite this is equal to 4, and this is the number that sits below the logarithm. So that's why it's called your base, because that's kind of what the logarithm is under. So you can just think of it as kind of like the ground for the foundation for your logarithm. That's it. That's all that is. And also just another important tip. When you write log base 10 to some power, let's just say x, then that is equal to just log of x. When you take something to when your base is equal to 10, you do not need to write the 10 under here. Like even if you look at like basic calculators, you'll just see a button like that just says like this, like a button that says has this on it, and that is basically telling you that this is going to give you something that has 10 as your base. And that's because 10 is very common, is a very common base. Like even with a lot of, even chemistry and other science, you often use this log here. So that's why it's the most common used base, and that's why it's on most calculators. So if you see something like log 3, don't freak out. It's just the same thing as log base 10 of 3. Okay, that's it. So now let's move on to a few tips that will help you in doing other logarithmic stuff. So let's go. Alright, so the first little tip I want to show you is that when you add logarithms, you're basically multiplying them. Now you may look at that and you'll be like, whoa, what are you saying? But it's actually pretty simple. Let me just show you the in-depth explanation first. So, or rather, let me just show you a quick example. So if you have log base 2 of say x, and you add that to log base 2 of y, then you're gonna get log base 2 of xy. It's as simple as that. Now for a little explanation of how this works, we're gonna have to go back to the exponents. We're gonna have to go back to our exponents. So if you had say 2 to the x power and you multiplied it with 2 to the y power, what would your answer be? It would be 2 to the x plus y power, right? And what are logarithms? Powers. So when you multiply them, you add them. So just keep this in mind. And once again, it just shows how important your exponents are. So you need to refresh your exponents. And if you want, you can just pause this video and go back and just go and read back on your exponent notes or whatever if you have some, or watch another video on exponents. But make sure you know your exponent rules pretty well, because exponents are a key part of studying logarithms. Okay, so having said that, I'm just gonna get on to a little example of where you would use this, like how is this useful. So basically, let me just give you a little example here. Okay, so this example is log base 2 of 128. So now you may not know out of the top of your head what 2 to the what power is 128. And so basically we can split this into two smaller logarithms using this property. So we can split this up to, let me do this in different color. Yeah, we can split this up to log base 2 of 32 and log base 2 of 4. I like these two numbers because they're pretty small and easy to work with. If you want to use other numbers, you can, but just make sure they multiply to equal 128. Okay, so 2 to the what power is 32, that is 5, I believe, and you add, and 2 to the second power is 4, so plus 2, that gives us 7 as our final answer. And if you plug this into a calculator, you would also get that the answer as 7. So that's how you would do it. But this way is just a little more quicker, and also means you have to rely less on your calculator, because these are pretty small exponents. You should know them pretty well. But as you get to bigger numbers, you may want to have a calculator in handy as well. Okay. So yeah, that's about that's about how you'd use these. And also just keep in mind that you cannot use this property unless you have the same base here. So for the same reason I mentioned over here in when I was explaining the property of the exponents. So if you've got 2 to the x power plus 2 to the x power times 2 to the y power, it's 2 to the x plus y. But if you've got 2 to the x power times 3 to the y power, that is not going to give you something, and that's not going to be anything like this. So you cannot do this, apply this property, unless you've got the same base over here. So just keep that in mind, don't get confused. Just make sure you've always got the same base over here before you use this property. Okay? So on to the next type of problem. So when you subtract logarithms, you're dividing them. Again, just the same concept we applied in the previous one using exponents. So if you've got, let me use a real number. So you've got 2 to the x power divided by 2 to the y power. This would be 2 to the x minus y power. So that's the same way it would work over here. You're going to subtract your logarithms and basically use division. Actually, it's supposed to be the other way around. When you're dividing logarithms, you subtract. So whatever. Other way, this is the same thing. So I'm just going to get a little example over here. Yep. So log base 3 this time of 27 over 81. So straight away you could simplify this fraction if you want, but I'm just going to take it with this sort of setting before I do that. Oh, and I need to write that down. Just give you a little example here. So log 3 of, let's see, x minus log 3 of y equal to 3 of x over y. Okay, that's the basic formula. So we're just going to do the same thing. So log 3 of 27 minus log 3 of 81. So again, we could use the addition property to split up these logarithms into smaller ones if we wanted to. This one is pretty basic. 3 cubed is 27, so answer here is 3. And for this one, it's a little bit more complicating. So we could split it up using addition, but for the sake of time, I'm just going to tell you the answer right away. And the answer is 4 minus 4. And the answer would be -1. Now again, -1 you may think is a little bit weird, but if you actually took 3 to the -1 power, let me just do that in different colors so you can distinguish. So if you took 3 to the -1 power, that is basically 1/3. Just flip the thing. When you've got an inverse power, just flip it. And if you simplify this fraction, it actually turns out to be 1 over 3 anyways. So 3 to the -1 power is 1 over 3. So yep, just again, keep in mind that you may get negative logarithms as well. So negative exponents as well. So a logarithm cannot be negative, by the way, because yeah, it cannot be negative. I'll explain why later. Sorry about that. So yeah, on to the final example. So when you have a power, you bring it to the front of your exponent of your logarithm. So basically, if you've got something like log base, let's do 5 this time, to the x squared power, that is basically going to be 2 times log base 5 to the x power. Yeah, that's about it. So this is again pretty simple, and I could also show you this using the exponent properties. So let me just put this in red. So if you've got, say, I'm going to do 3 this time, 3 to the x power, and all this to say the y power, this is the same as 3 to the xy power. So once again, just make sure you look up your exponents and know your exponent properties, because it's pretty important and can also just like help you understand why this is the way it is better. Okay, so now let me just show you my little example here. There we go. So I made it pretty obvious here what the skew of the square is, so where your exponent is. So if you just look at the property over here, this is pretty basic to simplify, so you could just simply make this oops, 2 times log base 4 of 16. And you could take this another step and you could just take this another step forward. And what squared is 16? Is 16 a perfect square? Yes, it is. This is the same thing as 4 squared. So you could take this another step forward and just pull out another 2 from over here and just simplify this as follows. 4 of 4 squared. Sorry for my cramming it up. And you would be able to pull that 4 out again, so another 2 out. So it'll be 2 times 2 times log base 4 of 4. And if you simplify this, that would be basically 2 times 2 times 1, which is 4. Pretty simple. So yep, that's about it. And finally, I just want to show you this example here. Again, this is not a different problem, but when you've got a radical here, you just have to do one more step to make this something that you've seen before. So a radical is nothing more than I'm just gonna go back to my properties of exponents here. So a radical of x is nothing more than x to the square root, in this case, x to the 1/2 power. That's what this is. So if you've got a radical, then mostly you'll be able to find a fraction exponent for that particular number. So in this case, this would be log base 2 of 8 to the 1/2 power. And then, as we learned in the previous one, just bring the power in front. And if we read out this, it would be half of log base 2 times 8. Okay, and if we simplify this, 2 to the 3rd power is 8, and half of 3 is equal to 1.5, or 3 halves. Yep, that's basically it. So the key thing about all these properties I've just taught you are that you can use them to simplify logarithms, make them a little bit easier. You could definitely solve all of them without these properties, but it would just be a little bit harder, and this way you could save yourself a little more time. And also you could do most of these by hand rather than rely too much on a calculator. It's wonderful to have a calculator. I use my calculator a lot. It's super effective. I've got a TI-84 and it helps me a lot when I'm doing math. But all the same, it's good to be dependent on your own brain and hand as well. So just good to keep that in mind. And I hope this video was helpful. I'm gonna post some practice problems as soon as I possibly can, and I'm gonna be doing them with a little bit of step-by-step explanation so that you can see how it's done again and again, and hopefully get a good grasp of the concept. So I hope this video is helpful. I did not put stuff too much in this video. I hope it's a bit long nonetheless, though, only 20 minutes I think. I hope I haven't bored you. So please do subscribe. I know I don't post on a very regular basis these days, but I still do post, so you can just check out some of my stuff. And I don't just post about math. I do chess occasionally, cricket stuff, and obviously math as well. And I'm thinking of doing some other stuff. So anyways, yep, thanks for watching. Please do subscribe, of course. See you next